Hello, I am Rochelle Dietz. I'm one of the graduate research assistants on Project Mindset. And this is just a brief tutorial to introduce you to the project before perusing our website. So Project Mindset uh, is an acronym for mathematics instruction using decision science and engineering tools. The project is a collaboration among math educators, engineers, and mathematicians at North Carolina State University, University of North Carolina at Charlotte, and Wayne State University in Detroit, Michigan. The objective of the Mindset Project is to create, implement, and evaluate a new high school curriculum that integrates mathematics and engineering concepts. That's where the decision science and engineering tools comes into play in the acronym. The curriculum is intended for high school seniors who have completed 2 years of algebra and 1 year of geometry. And that's really how this project got started. In the states of North Carolina and Michigan, they passed a law requiring high school students to have 4 years of mathematics in order to get a high school diploma. And so there was the pre-calcs and the calculus and the AP Stat, but there wasn't really any place for students who traditionally haven't been successful in mathematics to go. And so the collaboration among all of these different people came together to create this curriculum to provide a really rich setting for those students who traditionally wouldn't really have any other place to go in their fourth year who wanted to take a fourth year mathematics. The Mindset Project is in the last year of a 5 year program, and that program is funded by an NSF DR K-12 grant. So who are the people of the project? Well, the principal investigator is Dr. Young. He is an industrial and systems engineering professor at North Carolina State. The other co-PIs are Dr. Keene and Dr. Norwood, who are also at North Carolina State University. They are math educators. Dr. Pugley, who's both in the math department and the education department at UNC at Charlotte. And then Dr. Chelsea and Dr. Edwards, who are at Wayne State University. Dr. Chelsea is an industrial engineering professor, and Dr. Edwards is a mathematics education professor. And really, they are the origins of this project. Dr. Chelsea and Dr. Edwards, several years ago, created a really nice supplement of OR context in a workbook that teachers could use in their classrooms. And the title of this workbook is called When Does This Line Ever Move? From Key Curriculum Press. And so when they applied for the grant, they applied as an extension of this workbook and turned it into a full-fledged 1 year math class. So the title of the curriculum created by the Mindset Project is When Will We Ever Use This? Making Decisions Using Advanced Mathematics. As you can see, there is a picture of one of our covers. And teachers in North Carolina, Michigan, California, and Georgia are implementing the curriculum in senior level mathematics courses. North Carolina and Georgia State has adopted it, and so in Georgia right now it is its own course for a fourth year mathematics class. In North Carolina, it's been implemented in other fourth year mathematics courses, but it is now its own full-fledged course. The state of California, the UC system has recognized it as a appropriate fourth year level math class to then apply to the UC system. And there are many other places and states where it is being implemented. Teachers love it. Students love it for the most part. We're not going to win over every student. But overall, it's just been really positive, and I think teachers and students, speaking from personal experience being in the classroom with them, teachers and students just enjoy how different it is and how real life it is, much more so than traditional K-12 mathematics. So we call this curriculum a mathematics for decision making because the emphasis is on that decision making, using mathematics to make good decisions. The content is based upon contextual problems from business and engineering as well as student lives. It is very context rich. The content employs multi-step problem solving tools, so it's just very different from what you traditionally see as far as word problems go in the back of each section of a math textbook. And as I said earlier, the emphasis of the curriculum is for students to make decisions concerning the context of the problems. How am I going to maximize my profit? What's the likelihood I'm going to get a failure? Those kinds of questions. So the content of this course is split up into two halves, the deterministic half and the probabilistic half. And then the deterministic half, the bulk of the chapters is on linear programming, min and max programming, sensitivity analysis, which looks at how sensitive solutions are, integer, and then integer and binary programming. However, there are lots of different, there are other chapters. A lot of emphasis also on networks and graphs. You'll find optimal location, shortest path, and then CPM, which is used in the real world for project planning. And then the opening chapter is multiple attribute utility theory, which is a means to make a decision, such as which car should I buy, what college should I attend, which cell phone plan will be the best for my needs. The second half, probabilistic methods, covers more probabilistic uncertain topics such as decision trees, distributions, binomial geometric normal, and so on. Quality control, which is probably from people in the industry when they look at our book, the chapter they're most excited by because companies have to spend a lot of time training employees on quality control techniques that we actually cover in the chapter here. False positive and negative, such as a false positive medical test. Simple queuing systems, what is it like to stand in line, and what do you look at when you do stand in line? PERT, which is another project planning tool, and then Markov chains. Now, for each of these chapters, I should mention that no teacher has taught all of these chapters in 1 year. However, teachers have taught all these chapters over the course of different classes just because they were interested in them. These chapters, for the most part, stand alone for themselves. There are a couple chapters that have prerequisites, such as in order to teach the programming chapters, you need to teach the first programming chapter. And in order to teach the distribution chapters, you need to teach the introduction chapter to probability. However, our teachers really just pick and choose, and sometimes they'll teach the probabilistic first, and then they'll teach the deterministic, or they're flip-flop. So there's a lot of freedom and flexibility based upon what the teacher's interested in and what he thinks their students will be interested in. So the general structure of a chapter is very different from a normal math textbook, a traditional math textbook. Typically in a traditional math textbook, you have chapters that are broken up into sections. In those sections, you have some sort of box that summarizes a formula or a technique, and then you have examples showing that technique. And then at the end of the section, you have a slew of homework problems. Typically, they're out of context. They're just normal algebraic problems that you need to solve. And then at the end of, once you've covered every section in the chapter, there's normally some sort of review and then a chapter test. This is not what Mindset looks like. In a typical chapter for Mindset, there are only 3 contexts for the entire chapter. The first problem or context is an introduction that really motivates the reason for this problem-solving technique or this type of mathematical modeling. The second problem is another context, and it explains every step in the process. And it also teaches students how to interpret solutions, what they should be looking for, what should they be considering, those kinds of things. And then the third problem, because this is a decision-making curriculum, actually presents the entire solution. And then students are really expected to interpret the results and dig deep into the context of the problem. And this is why we call a decision-making course, is because just because you have an answer doesn't mean you have a solution. You really have to spend time exploring the constraints and the issues that context poses and how those issues and constraints affect the solution. I highly recommend that you check out mindsetproject.org. You can see sample chapters, so you can see what I'm talking about with this really context-rich 3 problems. There's a lot of words. There's no formula boxes. There are homework problems, but they look just like the context. So again, very meaty, very contextual. There's also more information about the project, and you can access the help desk. So if you have any questions or if you want to know more about the project, you can email the help desk, and we will respond very promptly. Thank you very much.